Okay, so have you had a chance to look at this picture? Any thoughts about this graph? What is it showing us? I know that's kind of a broad question. What's the graph about?
So it's showing us life expectancy at different ages
Okay.
during like over years.
Yeah. So when you're looking at a graph, right, my recommendation is you're looking at, obviously the title of the graph should be really important. It should tell you something directly about what what the graph is supposed to tell you. But the x-axis and the y-axis also are important things to look at. Then you've also got the paragraph before and the paragraph after, as well as any kind of notes. Sometimes there's captions in the bottom. This has some captions actually in the text here. There's a key here that's telling you something about the different lines that we're looking at. So I imagine you have a concept of what life expectancy is because it's pretty self-descriptive. It's how much life you expect to have. But it's actually kind of a complicated thing to calculate. I mean, there's a child born tomorrow. How can we predict how long this child is going to live? Well, we really literally have no idea, right? But actually, we do have an idea based on statistics and numbers and other people who were born at a similar time and have lived this long. So what we're going to do with this first part is we're going to just use the concept of life expectancy to dig into descriptive statistics. We're not going deep into descriptive statistics. We're just going to look at mean, median, mode. Um, I think the concept of range may be something that some people have heard of. You're not going to ever be asked that in a homework or a test, but I think there's a question in Excel about range. And again, you know, instead of just giving you a bunch of random numbers and saying, hey, let's talk about mean and median, we're trying to do it with something that has context and meaning. And I like that about this class. I think it's important. And I don't want you to get overwhelmed by it, but I do want to pause and kind of reflect on the life expectancy question and issues that it raises about our society. I mean, the first thing that you notice when you're looking at this graph is that life expectancy has generally gone up as the years have gone by. So as we go to the right in this graph, these dots seem to get higher and higher and higher. And that's reflecting the fact that we've made tremendous progress in healthcare over the last century. And this is, 120 years ago, 1900. And some of the biggest gains were in caring for kids and in keeping kids safe. And that's been a huge advance. I mean, back here, 1900, 1910, it seems kind of wild to think about, but people didn't even know what germs were. So you had these, I was listening to a story recently about doctors, there was some weird syndrome that would happen where some pregnant mothers would just like get really sick and die. Not pregnant, new mothers, people who had just given birth. And this doctor finally figured it out. That the doctors were working in places where they were cutting up dead bodies as a way of like learning more about anatomy because they were fairly ignorant back then. But they didn't know anything about germs. So they would cut up a dead body, then they'd go deliver a baby, and they wouldn't wash their hands because they didn't realize that something as simple as washing your hands could take germs off your hands, which would save lives and keep people from getting sick. So this is just a simple example of how people's knowledge has improved. Lots of other things have improved, and it's all led to generally higher life expectancy. So that if a baby is born now, we can look up the real numbers here, but it's, you're probably going to live somewhere between 70 to 80 years on average, right? That doesn't mean everybody gets to live between 70 and 80 years, but that's the average kind of life expectancy in this country. Okay, so let's look at the mechanics of life expectancy. So the way it's done is you would go to somewhere that keeps records. So this would be like your county office, the clerk's office. And anytime someone dies, there has to be a certificate of death. And it says how old the person was when they died. So you could theoretically go and just look at a bunch of pieces of paper. Now this is all would be on a computer, but you could just look at a bunch of people who died and you could take the average, right? So that's kind of a starting point for understanding what life expectancy is. We just look at the average age of everybody who died in a certain place in a year, and that gives us a measurement of the life expectancy. Okay, so in this box here, they give you some definitions. Mean, most people, when they say mean, they are thinking average, or when they say average, they're thinking mean. Mean is where you add up all the numbers and you divide by how many there are. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's nice. So we add up these numbers and then we divide by 10 and we get our mean. The median is the number in the middle, and the number in the middle can be a little complicated if there are two numbers in the middle. Like in this case, there are actually two numbers in the middle. So what we do in that case is we just add these two up and then divide by 2 to kind of take an average of the middle two numbers. That's how we get the median. If there's only 9 numbers, then there's only one number in the middle, and that's the median. And we'll talk more about the difference between the mean and the median as a measure of the center, because that is a fairly important distinction and concept that that you might not have thought much about if you already knew about mean and median. Okay, so let's go ahead and do 1, 2, 3. Shouldn't take too long. I'll maybe just be quiet for a minute here. We're on page 56, and you're just doing 1, 2, 3. That's the mean, the median, and then just a quick thought about how the mean compares to the median. So I'm going to show you that Excel can do this calculation for you, which shouldn't surprise you if you've been keeping up with our Excel assignments. Excel is a powerful tool. It's a calculator. Now, I could do this, and you probably did do it with your calculator, but with Excel, I'm going to use the same idea as I did with sum. I'm using the word average because I'm not just doing the sum, I'm doing the average. That's the way Excel thinks about it. But I highlight all the numbers I want, close a parentheses, press return, and that gives me the mean. So you should have got 37.7. Now, if you didn't get 37.7, there's various reasons why that might have happened. You could have added up the numbers wrong, left a number out, mistyped a number, could have done order of operations wrong and divided by 10 before you added everything up. So there's various reasons why that wouldn't come out right, but you should have got 37.7. The median here would just be, again, we circled the two numbers in the middle, but I can just tell Excel, hey, look at all of these numbers and tell me what the median is. And 40 is the number that's halfway between 34 and 46. So if I take 34 plus 46, that's 70. Sorry, 34 plus 46 is 80, and then I divide by 2, and that's 40. That's where the median comes from. When it's asking you to compare the mean and the median, at the very lowest level, in a non-quantitative response, you could just say the median is larger than the mean. Okay? That is a qualitative description. I'm just saying one of them is bigger than the other. If I wanted to go further, I could, find the difference, because often a comparison, just starting with the difference, says, how far apart are these numbers, or how much larger is the median? Just a little side question here. What are the units? Because anytime we work with numbers in a context, the numbers have meaning. So what are we talking about here? 37.7 what? Hot dogs? Cups of coffee? 40 what?
Years.
Yeah, it's years. It's years because these were the people's ages when they died, and presumably we were measuring those in years. So this is a 4-year-old, 7-year-old, 12-year-old, 22-year-old, right? Does it make sense, thinking about the context and rounding, does it make sense to say 37.7 years? Could you have 0.7 of a year?
Yeah, months or however many months that would be 0.7 of a year, I guess.
Right. So I mean, a year is not like other objects where it's hard to chop it up into parts. Like time is infinitely dividable, so we can easily divide time into smaller units. 0.7 of a year is a pretty meaningful amount of time if you think about life and living another 0.7 years. I'm sure people would take it over not having it. So absolutely, the decimal makes sense here. Okay, so just to go back to one of the things that's kind of weird about this graph, because they have life expectancy at birth, that's this bottom line. Then this next one with the rectangles is life expectancy at age 20. So you might be asking yourself, what the heck does that mean? Well, it tells you right here. If we set the benchmark to 20, that means we're only considering people in our little sample who lived to be 20. So we would actually take out the first three numbers and we would recalculate the life expectancy, ignoring this one and this one and this one, because these poor children didn't even make it to 20. So a life expectancy at 20 is calculating the mean, but only looking at those numbers. Okay, so let's just go ahead and redo that mean and median calculation real quick. So I'm just going to go back and do this in Excel. So I'm going to take this same list of information. I'm just going to move it down here. In Excel, it's easy to just get rid of those and then recalculate the average of those numbers. So this is the number you should have got if you do the life expectancy at 20. And I can do that same concept again. But if I take out everybody who didn't make it to 60, then the life expectancy at 60 is 69.5. So you're not going to be demographers. You're not going to be expected to calculate life expectancy by hand ever. So this is not the point of this, is that you understand thoroughly what life expectancy is. We're just practicing taking the average, and which is called the mean, and we should also be able to find the median. Now, I want to kind of illustrate the important distinction between the mean and the median with an example here. So let's say I have a block of people, and I'm very nosy, and I just go around and ask people how much money they made last year. So take something like people's adjusted gross income, and I just ask my neighbors, tell me what was on your tax return last year. And we got a mix of people on the block. I'm going to take the comma out of here. Well, I guess I could turn this all into money, since we're talking about money here. And I'm just going to put one more person on the block. Okay, so the mean is 40,500, and the median, remember I got to start with equals to calculate. Just highlighting the data I want to do, is 34,500. Now, these are both measures of central tendency. And that's just a fancy way of saying where is the center of the data set, right? So I use these numbers to talk about the average person, like the average person on my block makes $40.5 thousand or $34.5 thousand. Those are pretty different answers. I mean, they're $6,000 apart. So you might be saying to yourself, well, that seems like a pretty big difference. Like which one I choose could really matter. And that's true. I mean, it's an important thing to remember about statistics is that statistics are objective in the sense that, they're just calculations, but they're not objective in the fact that people can't manipulate numbers or data sets or choose specific statistics that kind of support what they're trying to say about an argument. So this is one of the things that's very interesting about us at this time in this world where so much information is available online, and you really got to think about and be a critical consumer of people's information and ideas. And we're not actually as good at that as we might think we are, because we all struggle from confirmation bias, which means if we hear something that confirms what we already think, then we're like, oh, yeah, that's a good point. But if we hear something that goes against something we believe, we're like, God, where'd you get that information from? That's garbage. So, anyways, I want to consider another block. First thing about descriptive statistics, can you tell from looking at this set of numbers compared to this set of numbers who's got a higher average? It's only 10 numbers. Who do you think, which block has a higher average? And by average, I'm talking about mean in this case. Who do you think has a higher mean? Can you tell? I mean, I see Emily shaking her head. It's not an easy question. It's a lot of numbers, right? I mean, 10 is not a lot of numbers, but at the same time, it is a lot of numbers, right? How could you possibly just look at this and say, oh, I know which one has a bigger mean? You might think, oh, well, block B has this person who made $189,000 in it, so that's probably going to really impact the mean. You might be right. Let's find out. Oh, remember, mean is not the word that you use here for Excel. Use the word average. Okay. So yeah, it actually was quite a bit higher. Let's check out the median. You think the median is also going to be higher? Okay. Yep. So they were both quite a bit higher than in block A. So one of the things that I want you to take home about mean and median is that it's a way to talk about a group of people at once so that we can make comparisons between places, block A and block B. We can say, well, on average, people on block B are doing better than people on block A. Does that mean that if you live on block B, you are doing better than someone who lives on block A? Right? Because statistics obscure the kind of variations and the little nuances of things. So we've got to be a little bit careful when we look at statistics and say, well, you see the average here is higher than the average over here, because that's the average. That's what we get when we add everything up and divide it out. And it does say something if the average on block B is higher than the average on block A. Maybe. But maybe it's just because of this person, right? Maybe if we took that person out and compared everybody else, it would really be kind of roughly the same. I mean, this is the thing that I'm saying about statistics. We can crunch the numbers in a way that kind of helps us prove our point about whatever we're trying to say. Now, one thing I want to really drive home about mean versus median is the impact of outliers. So let's pretend that somebody fabulously wealthy moves onto our block. I don't know why they're moving onto my block or your block, but that they just they're like, I want to come and live with the real people. So this person makes, what's the biggest income you can think of? Not a fake income, a real income. And I'm not talking about wealth, or I'm not talking about the wealthy people, because there's a difference between wealth and income. Income is about the money that you earn every year. Wealth is about the assets that you have, and we looked at that in Excel too. That's why people like Bill Gates and Jeff Bezos have a lot of wealth, because they own companies. They have a lot of stake in companies. So that's an asset, but that's not like cash in their hands. I'm sure they got plenty of that too. All right, come on, give me somebody.
All right, Michael Jordan earned $145 million in 2019.
Okay, well, that's not bad for old Michael Jordan. All right. So for whatever reason, Michael is moving onto my block. Let me get this number right here. 145 million at 6 zeros. That was his income. Okay. Let's just look at what this does. Oh, it's already adjusted my mean. Yep. Right. And let's take a look at how it impacts the median. I don't think it's including that for some reason. Okay. So what do you notice there? Which number responded drastically to this new person on our block?
The mean.
The mean. And if you think about mathematically why that happens, the real kind of conceptual definition of the mean is that we take everybody's money, we pool it together, and then we redistribute it equally, right? So Michael Jordan's $145 million. When we're taking the average, we're like spreading it out equally. Like, okay, you need 13 million to bring you up to the average, and of course that's not reality. That's not how we operate here. The median changed a little bit because now the middle number is slightly different than it was before, but it wasn't dramatically affected, and it's still, the 35,000 is still a reflection of the average person on the block. I mean, yes, there's this guy called Michael Jordan who lives on the block who's incredibly wealthy and is making a lot of money. But the average person has not changed, right? There's 10 other people on that block who are still making the same amount of money they were before. And for this reason, the median is often superior or preferable zoom to the mean, because it is less susceptible to being skewed by very large or very small numbers. And so you'll see this a lot, especially when you're talking about income, or you're talking about house prices, or you're talking about other things where there's an end of the scale that really doesn't apply to the average person. So you take incomes, you talk about wealth, you talk about house prices. We can imagine that, even in the state of Indiana, which is just this little state in the Midwest, there's still houses that are worth millions of dollars in Indiana, right? We're not talking about Beverly Hills, but there's still houses in Indiana that are worth a lot of money. If you just add that into the pot and then divide it up, what it does is it skews the average. And medians aren't susceptible to that because the median just looks at the number in the middle. And so a lot of times when you're looking at data, when you're looking at that kind of stuff, it'll talk about average in terms of the median. The average person is the median, which is the person in the middle. Okay, so that's an important concept. Let's bring in our friend mode here. We'll just look at this example real quick. This is page 57. Go ahead and do the mode, median, and the mean. Good eye. Okay, so that actually changes the mean a little bit. It should be 20.1. Then the median becomes 213. Give myself another decimal here, 12.5. There you go. And what's the mode?
12.
Good. And mode, you've got a couple different options here. I would just use mode if you are allowed to on your computer. 12, right? So one of the things that's important is that if your data is not organized, it's good to put it in order. And that will happen on the test. I think there's a test question, one test question that deals with this kind of stuff, and you need to put it in order. So don't just take it as it's given to you. You need to process it, probably least to greatest. That helps you with both the mode and the median. It doesn't help you with the mean, because the mean, you just got to add them up and divide by how many there are. But for the median, you want to be able to see which one is in the middle after they're put in order. And for the mode, it helps to have them grouped together, because then you can see which one appears the most. And I can see there's 4 12s there. Now, the larger point of this question is that, kind of what I was just saying, is that the best measure of the center is not always the mean. It's not always the average. Is the average person here 20 years old? I mean, technically, the average, the mean, is 20.1 years, but it doesn't make any sense to say the average person is 20 years old, because there's no 20-year-olds at this show, right? What kind of show is this? I don't know. Who are the 13-year-olds watching these days? Why is there a 37-year-old at this show? What about the 44 and the 50-year-old? What are they doing? They just happen to like this K-pop boy band? No, they're probably chaperones, right? But they have an impact on the mean. They don't really have an impact on the median in the same way, because the person in the middle, it doesn't matter whether that's a 37-year-old or a 27-year-old or a 17-year-old. It doesn't impact the median. It didn't impact the mode, because the mode was just what was the most common number. So sometimes the median and the mode are better ways of describing the center.